Hello, everyone. My name is Olaf Gipser. I'm very happy to be part of this webinar. The project I'm going to talk about is a residential tower in Amsterdam North. We started to work on that project in 2015 and finished it in 2021. The site of the project is a typical post-industrial site to the north of Amsterdam. You will see in the image on top, for those who are acquainted with Amsterdam, you see a central station across the canal. And behind central station, on the upper edge of the image, you see the half ring of the canals of the center of Amsterdam. And we are outside, we are on the north side, which has been traditionally the back side or the backyard even of the city of Amsterdam. It has been a place where first was a swamp, then the industrial harbor expanded in this area. Then it was a place of accommodation for poor people, for uneducated people. It was a place where, so to speak, everything was dumped that was not welcome in the center of the city. That has changed through globalization. The harbor went down. The area became, again, a typical post-industrial vacant site that is now under development. The city of Amsterdam has the ambition to make of that former problematic area a forward-looking urban development that sets high standards for sustainability, particularly in terms of circularity. This is the context of the project. The residential tower is essentially a participatory project of, in total, 35 parties that was initiated by the city of Amsterdam. The city of Amsterdam gave grant to 6 plots, of which we were able, through an application process with our participants, to design and build on one of them. This participatory process means that the residents are not consumers who buy a ready-made product on the market, but on the contrary, who are engaged from the beginning of the design process to the delivery and beyond, in engaging in what it would mean to set up a development of a dwelling space, of a living space. And that poses confronting questions. It poses ethical questions: where to put the money. Do you put the money in your private square meters to maximize them, or do you put money in shared areas? Do you put money in sustainable material? All of that, the group as such, as a whole, takes responsibility. Individuals do matter, but in the end, it's the collective that decides. I always talk about collective intelligence because everybody has an expertise, and the expertise of everybody together, let's say, stabilizes and made also in this case, really the intelligence and the ambition of that project. This is the area in Amsterdam North, which in fact comprises a number of really innovative buildings developed from colleagues, also from us. We see stories in the front. We also see from this moment of the construction that one ambition that we had with stories was to build with timber. And this is a subject I would like to address a little bit further. The building is a hybrid construction with a concrete plinth of 3 floors and a tower up to 45 meters height, 10 floors of timber construction. In fact, of a CLT construction, cross-laminated timber panels. The volume was given by the city. We could not do anything with that besides to fill it. The reason why we chose for a concrete in plinth and not the entire project by timber is on one side a technical reason, on the other hand a psychological one. The technical reason is we have a large parking hall underneath the tower that required some constructive gymnastics, for which concrete was a more suitable solution. The psychological reason was, it was in the year 2015, there was no previous project, no reference in the Netherlands that would go up to 45 meters in timber only. So we were aware that this is going to be a timber, this is going to be a pioneer project. And as a group, together also with our advisor and with the contractor, who was in fact from the beginning present and important in the building process, we decided to focus on the 10 stories of the timber and do the plinth below in concrete. The construction, the timber construction, is based on three elements, on three system elements. We have a vertical wall panel from CLT resting on a horizontal floor panel, and in fact having two wall panels connected with a beam. So these are the three base elements, and they make up the whole modularity of the construction. What you can also see here is the node, the connection node between the vertical and the horizontal members, which are articulated here as a kind of a interlocking teeth structure, because one of the technical requirements of timber construction is not to put the loads across the direction of the timber nerves, but with the direction of the timber nerves. So through the interlocking with teeth, we safeguard a vertical flow of the forces and still have the possibility to support within the verticality of the panels, the horizontal member connection. This is an image from a construction site, 24 centimeter thick vertical timber CLT wall panels. You see the electric installations is engineered into the panel. You see also on the image the teeth structure prepared already with an elastic membrane to prevent sound transmission from one floor to the other one. You can also see in the beam element crossing two of the vertical elements that there are openings for the mechanical ventilation. And you see the left one has even a reinforcement in wood as it is closer to the moment of the support of the beam. The CLT timber construction is then covered with a floor of 16 centimeter thickness. This is further during the construction process combined with installations. We have installations on top of the floor that, as you will see later, will be covered with a mass layer. The reason for that is that we wanted to give to the participants of the participatory process a great degree of freedom where to arrange their individual necessities that have water or that need electricity. And this freedom, in a sense, reflects also the construction layering of the installations on top of the timber floors, then being covered with a mass layer for acoustic reasons. I show that in more detail with this exemplary knot of a vertical and a horizontal structure. We have above the horizontal structure of the floor, we have a 10 centimeter mass layer that, as I was just referring to, that does take up the installations. in order to soundproof them also. And as a mass layer, it prevents acoustic transmission between the floors. In our case, this is done by bubble concrete. This was an outcome of the construction process. In the first instance, it was limestone gravel. In our case, it was supposed to be bound. I think the ideal scenario would be to have the limestone gravel unbound, because then you deal only with dry construction material. Of course, in our case, it is an evident contradiction to combine dry construction method of the timber, which is remountable, demountable, with a wet construction such as the concrete, the bubble concrete. But here the worry was, as part of that pioneering process, the worry was the sound transmission. And here we chose against the construction logic, against the possibility of a circular disconnection of the elements, for saving, for making sure that the sound transmission would be good. So today we would for sure do that in a different way. The vertical wall elements are covered from both sides with a double layer of plasterboard, essentially for fireproofing. We have 120 minutes fireproof necessity in the Netherlands. But also they do, of course, contribute to prevent the sound transmission. This is a moment of the delivery. So the contractor delivered the rooms, the spaces, the individual owners, the individual participants finished thereafter their apartments with their own contractor, or even, let's say, with their own hands as a self-built, let's say, model. Next to the aspect of timber construction, there is another ambition that we try to achieve as much as we could, which I call open building. That is going back to a concept from the 60s. So there is John Haberhagen as one of the founders of that concept from that period, a Dutch architect, which is essentially the question: how can we make buildings, how can we expand the lifespan of buildings, so that also in future the spaces can be appropriated by the users and can be changed also programmatically. We have a number of answers or reactions to that ambition. First of all, the 6 bays, the 6 load-bearing bays with the portal construction, which in fact have an axis dimension of 4.80 meters. 4.80 meters is the bay width. They are portals, they are open, so the entire floor could be spatially or constructively organized for one function or for one user or for several, actually, in fact, up to possibly 6 users. Therefore, we have also a redundancy of doors, of access points from the central core. We have more access points than we needed today, but again, that's for a future possibility to change. Third, we have a ceiling height which is which is higher than the standard of dwellings in the Netherlands. So it's not 2.60 meters, but it's 2.90 meters, and therefore the building can accommodate commercial or office program in terms of, let's say, building code. Further, we have concentrated the shafts in the inner core. We have only 3 shafts in the area around, which is due to the need for mechanical ventilation as part of the energy codes, but they require quite considerable shafts. And lastly, we have a central core, and that is a fire compartment. We have only 1 stair. The escape routes go in 2 directions, to the outside and from the outside into the main staircase, which is a fire compartment by itself. By that, we could avoid to have a second staircase. We have it a whole group in our current fashion that can change in the future, but with the current fashion, we have 10 different apartments. In total, there are 35 units, and they range from around 45 square meters to around 250 square meters. A third theme is the facade. We have conceived the inner volume as a tight fit, energy optimized volume with no funny jumps for plasticity. It's really a simple, tight fit volume for energy optimization. But we combine that one with a zone, a transition zone between inside and outside. We believe not only in housing, but also in other functions, that the outdoor areas in future will be really more and more important due to the climate change, due to the fact that people spend more and more time in the interiors. So these transition areas between interior and exterior will be more important. So we combined our tight fit volume with a loose fit volume. And that's in fact a ring of a steel construction around that accommodates terraces, it accommodates winter gardens, but it does also accommodate around 16 double height spaces for vegetation, of which around 40 to 30 are conceived as ecological niches, combining low-growing trees with bushes, with grasses. And in a sense, conceptually, we conceived the building as a little step towards such a kind of a post-anthropocentric thought I was addressing in the beginning. The building as a shelf, as an industrial or a post-industrial shelf, offering living area, living space for humans and habitat for non-humans. Together with the ecologist of Smartland, an office based in Amsterdam, and the contractor for vegetation, we defined the vegetation based on criteria such as their contribution to biodiversity, their resistance to environmental pressures, particularly to the wind in the harbor area, but also to seasonal appearance, let's say, to the change of seasonality as part of, let's say, the expression of the building. This is an image of the nursery with the future, with our future inhabitants at that time. And this is, these are two of these areas, this interrelation of human, non-human as part of this deep facade. And essentially, again, the facade is a microclimatic transition area. It does cast shadow to the energy optimized inner volume. It does offer outdoor space. It does offer greenery in a post-industrial area, which is scarce today still of greenery. So this vegetation or these ecological niches were thought to be a first start for the further greening of that area. This is the picture, the front facade overall. And in its urban context, this is the entrance area with the plinth articulated slightly different. This is from the first season, so the vegetation, particularly the climbers that we have in the plinth area, are not, let's say, grown as far as of course they are today.
Thank you, Olaf, for your comprehensive and detailed presentation. I would like to record also your answer to a question.
Yes.
You show us your tower, which was pioneering in terms of wood construction, vertical wood construction. And then you clearly let us know that in Amsterdam, they had this policy, or this commitment to build in wood. And I would like to ask you, beyond the high-rise, the low-rise building, what do you see the future of wood construction for low-rise? And also for modular construction versus on-site construction?
No, thank you. But indeed, you address, I think, the themes that are currently connected with timber construction. There is a lot of research. There is also a lot of practical development. For instance, in modular construction, we see, for instance, again, from the perspective of the Netherlands, that there are new players on the market who do offer the entire services, including architectural design, until the complete delivery of either 2D modularity or even 3D modularity. Let's say the compact, 3D cell pre-arranged. And I think this is and this is also how they are geared towards. There is a market, there is a shortcoming of housing production also in Amsterdam, like in many other cities. And of course, that could be an instrument to accelerate and to fill in a certain part of that. I think with modularity is always the big challenge, the individualization of buildings related to urban, let's say, regulations, urban planning points of considerations, etc. I think that's always the challenge. There is also a challenge, of course, how to avoid the seriality and the repetitiveness of that, which is, let's say, a subject also that is currently again debated. I mean, it's a kind of a recap of a conversation that we have had already in the 60s. It's interesting also in the Dutch context, because the Netherlands has since modernity, since the 30s and 40s, a relatively high industrialized construction industry, much higher, for instance, than Switzerland. What I'm always wondering is, why did this modularization not work in the 60s? And why should it work now today? And I think currently and collectively, one is reinvestigating this question and looks for new ways to deal with that.